Good morning, Year 5. Welcome to your Friday virtual maths lesson. Today we're going to start, as we did yesterday, by looking at some questions that cover some of the things that we have looked at over the last few weeks. So in a moment, I'm going to ask you once again to pause the video, give yourself 30 seconds, and then we'll come back together and see whether your answers match my answers. Just before you do go, there's also a clock face here in the top right-hand corner that we forgot to look at yesterday. Today, there's a second one there. I want you to have a go at trying to tell the time that it's showing, if it's clear on your screen at home. If not, don't worry. Pause the video now. Let's go through the answers to these questions. Question number 1, write 7 hundredths as a decimal. So again, we've looked at hundredths and tenths over the last couple of days. I'm looking at 7 hundredths. You're picturing that 100 square. You're imagining 7 of the squares shaded in. Writing that as a decimal, it would be 0.07. The place value headers, remember, the one after the decimal point is the tenths. The one after the tenths is the hundredths. So the digit 7 appears in the hundredths column. Question 2, find 3/5 of 40. We did this earlier in the week with drawing bar models to help us visualize it, using multiplication and division, of course, as well to help us. 40 divided by 5 would give me 8. 8 times 3 would give me 24. Number 3, work out 11 twelfths, take away 2 thirds. You've got a subtraction. Take away using two fractions which have different denominators. Is 3 a factor of 12? Yes, it is. I can times 3 by something to get to 12, which means I can use 12 as my common denominator. The first fraction will remain the same because I times the denominator by 1 to get from 12 to 12. I do the same to my numerator, which means 11 remains as it is. Second fraction, 3 to get to 12. I times that by 4 to get there. If I do that, the denominator, I must do the same to the numerator. 4 times 2 would give me 8. I now have two fractions, both over the same denominator, which means I can purely look at the numerators. Remember, we're subtracting, we're not adding, so make sure you haven't mistakenly done the opposite of what you should have done. 11 take away 8 would give me 3. 3/12 is my answer. Some of you may have simplified that even further because you've spotted the both in the 3 times table. How many 3's make 3? 1 3 makes 3. How many 3's make 12? 4 3's make 12. So either answer would be correct. If it asks for it in its simplest form, though, then you would always need to simplify it and give it like that. Question 4, how many lines of symmetry does a square have? So symmetry means how many times can I fold it over and ensure that the corners meet without any bits flapping over the edge. I could fold it down the middle vertically, I could fold it horizontally, I could also fold it diagonally both ways, ensuring that none of the edges do flap over the edge. So it has in total 4 lines of symmetry. We're now going to get into this morning's lesson. The what for us this morning is to understand thousandths. So we've looked at tenths, we've looked at hundredths. We are now going to today focus on thousandths. To help us do that, we're once again going to use pictures and 100 squares to help us visualize what it is that we're looking at here. Today I'm going to use these pictures quite a lot. So we just need to make sure we know what each one is representing, so when you do see it on the screen, you're understanding what I'm talking about. If I am using the cube here, the cube is representing how many holes I'm looking at. So whenever you see a cube, you're thinking of holes. If you see the square, I'm thinking of tenths. So 1/10 or 0.1. I'm writing it as a decimal. if you see the rods, I'm using those to represent 1/100th, written as 1/100 or 0.01. And then finally, if you see me using the cubes, I'm using the cubes to help me understand or represent 1,000, which can be written 1/1000. I've run out of space for my final 0. Let's squeeze it up here. Or 0.001. So we're going to be using these to help us represent numbers, decimal numbers. These represent wholes, these represent tenths, these represent hundredths, these represent thousandths. Let's have a look at an example. Here we go. So if I was to ask you what number is being represented here, I've got two wholes. Remember we said those big cubes represent wholes. So I've got two of those. I need my decimal point in because we talk about tenths, hundredths, and thousandths. I've got 3 tenths, 2 hundredths, and I've got 5 thousandths. So my number represented would be 2.325. Let's do another one. Let's have a look at this one. Make it a bit bigger so we can see. This time, I've got one whole, name a decimal point. I've got 4 tenths, 4 hundredths, and I've got 8 thousandths. 1.448. Talk about decimal numbers, I would always insist that you say the number, the digit, the value of the number, rather than saying all of these together. So I would always say 1.448 rather than saying 1.448, because 448, when thinking about decimals, is very different to 448, which would be numbers that we might see in the hundreds, tens, and ones column. So always just stick to repeating each digit as it appears, 1.448. If I was to partition this number, I could write it, so I could represent it using the pictorial method, I could write it using digits, as I have done here, or you could write it like this. So you've got one whole, add 0.4, 4 tenths, as we can see, add 0.04, would represent my hundredths, add 0.008. So each representation here is showing the same number. I'm just doing it in a varied way, slightly different way. Today you're going to do a little bit of practicing partitioning like so. You're going to have a go at interpreting some numbers, as I have done here. And we've got another few bits for you to be doing as well. We'll just have a look at a final example before we move on to the next bit. I'm going to bring in this example. This time, there's a slight change compared to the two examples previously we've just looked at. You might have spotted already, yes, I've got my large cube representing my wholes. I haven't got any squares though this time, which means that there's going to be a 0 in the tens column. Just because I haven't got anything doesn't mean I can leave it blank and write it without the 0. Because if you did that, your number that you'd be writing would be very different to the number represented. Remember, we said that the rods represent hundredths. So the rods have still got to represent hundreds, even if we don't have any tenths. So the number I have would be 3 holes still. We've still got holes, so we're still greater than 1. Still have a decimal point. I haven't got any tenths, so I've got no squares, so the 0 goes in there. I've got 9 hundredths, and I've got 3 thousandths. So the number, again, let's think how we say it, 3.093 as opposed to 3.93. So all that there will take you through the first couple of questions on the worksheet that I'm going to attach with this lesson. There are a few other bits though I want to go over, but if you are unsure of anything on the first few questions, it'll be what I've already covered on the video, which will help you with that. Let's move on. Now I'm going to bring up this square. Now yesterday and the day before, we were using 100 squares to help us represent tenths and hundredths. Today, because the Walt's talking about thousandths, I've brought up 1,000 square. So there's 1,000 individual rectangles. I don't often see 1,000 squares. 100 squares is something that we normally look at, but for this, we're representing it using a square of 1,000 rectangles. Therefore, each individual tiny thousandth, if I just shading one in red here, just to illustrate my point, if I shading one individual thousandth, I am representing there exactly that, 1 over 1,000. I'm representing 1,000th. I would need to shade in 999 more for me to shade in the whole thing. 1,000th is the same as 0.0001. Now, let's shade in a few more rectangles on my 1,000 square. In fact, I'm going to shade in 2, 4, 6, 8, 10. I really hope this is clear on your screen. I know the videos sometimes are a little bit blurry, but hopefully you can get the idea. When you get the sheets today, you'll be able to see it maybe a little bit clearer. So I've shaded in this time 10 of my thousandths. Let's write it down at the side so I don't forget. So I've shaded in 10 of my thousandths. 10 of my thousandths is shading in 1 of my 100 squares. So if you can look closely, a 0 on that. If you can look really closely, you can see that 10 of my thousandths make up 1 of my normal size squares that we looked at over the last couple of days. So 10 thousandths is the same as 100th, which I can write as a fraction like so, or 0.01 as a decimal like that. So if you can kind of imagine, if you're looking at the 1,000th square there in front of you, that each of them are broken, each individual square is broken up into 10 further rectangles. 10 of those individual thousandths shaded in would give me 100th, which, as I've said, you can write like so. I'm now going to shade in a few more on my 1,000th square. I'm actually going to shade in quite a lot more. I'm going to shade in all of this column. I'm not going to shade in each individual rectangle, but the whole column is what I'm looking at here. I'm shading in all of that in column. So what have I got here? I've got, if each one individual square has got 10 thousandths in it, what we just said a minute ago, I'm now going to shade in a further 9 of those 100th squares. So in total, I will have shaded in 100 thousandths. Again, if I think back to what I was doing the other day with tenths, each row, each column in its entirety represents 1/10. I've got one entire column shaded in here. So actually 100 thousandths is the same as 1/10, which can be written as 0.1 or 0.100. Let's have a look at a further example. Let's get rid of all of these out of the way. I'm going to bring up a new thousandth square. Here we go. Let's make it a lot bigger so we can see it. So this time, I've already shaded in quite a number of my rectangles. My question to you would be, what fraction has been shaded in? If I've got 10 individual rectangles in each square. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So in total, out of my 1,000 square, I have got 120 of them shaded in. 120 over 1,000. I could partition 120 thousandths into two separate fractions. I could split it into 100 thousandths which is what I've got here in my full entire row. We said 100 thousandths is the same as 1/10, one whole row. And as well as that one complete row, I've got two further squares which have both got 10 thousandths in. So in total, it would be 20 thousandths. Space, but try and squeeze that one on. There we go. So if I was writing that as a decimal, I haven't got any full square shaded in, so it would be 0.12. It'd be 0.12 because I've got 1/10 shaded in. I've got 2/100ths shaded in. And I've got no further individual thousandths shaded in. In total, I've got 120 thousandths. Let's look at one further example of interpreting thousandths on a 1,000 square. We get a little bit trickier. Right. Now, my question would be to you this time, what fraction again is shaded in? We said each individual square represents 10 thousandths. We had 10 squares shaded in. I've got 100 thousandths. This time I've got 1, 2, 3, 4, 5 completed rows, or 5 completed columns even, shaded in. So if each column represents 100 thousandths, 5 lots of that would be 500 thousandths. Remember, I'm only just, at the moment, I'm just talking about these completed columns. I'm not looking at this just yet. I'm going to look at that in a second now. Which is the same as 500 over 1,000 is the same as half. Okay, so if you put your hand over the uncompleted column, you can see that half of the 1,000th square is shaded in. Let's now look at the remaining bit that we haven't yet counted. So I've got 1 full square, 2 full squares, 3 full squares, 4 full squares, 5 full squares. We said there's 10 thousandths in 1 square, so in 5 squares I've got 50 thousandths. Because I've got 5 lots of 10,000. 5 lots of 1,000, sorry. And then remaining, I've got 6 thousandths shaded in. I ended up with 3 fractions here. 6 thousandths remaining in the uncompleted square. So in total, I've got 556 thousandths shaded in. 556 over 1,000. That's how I'd write it as a fraction. To write the decimal, 0. How many full tenths have I got? 1, 2, 3, 4, 5, we said. How many full hundredths have we got? Remember, we said 10 thousandths is the same as 100th. I've got 5. And I've got 6 remaining thousandths shaded in. 0.556. Lot of hard thinking there going on. So have a go. That section using the thousandth square will help you with questions 3 to 5 when you get into the worksheet this morning. So you might want to do the first few questions, then start having a look at it, maybe replaying that little bit of the video to help you with those questions 3 to 5. Last thing to finish with, we're going to have a look at a place value grid using decimals. Again, thinking about our thousandths. And I'm wanting to represent 4.013 on a place value grid. So I'm going to pull one in here like this. And I want to represent this using my place value counters. If I'm thinking about 4 wholes, I would need 4 counters in my ones column. Remember, we said the tenths, if it's got nothing in it, it still needs a place value hold of a 0 in there. So I'll be leaving it blank, but it's important that it's there. 100ths, and then 3 thousandths. Today you're going to have a couple of questions where you've got to interpret the numbers or represent the numbers in a place value column like that. Have a go at it. Like I said, play the video again maybe to yourself when you get to a certain question. See if you're finding it difficult, see if you can come back to the video, and that might help you a little bit. Email in your answers, see how you get on, and we'll be back on Monday for another virtual math lesson. See you later.